Imagine you want to build the largest automated ghost port on Earth. You cannot build it along a normal coastline or a city river. Instead, you must look 32 kilometers out into the open ocean. Your goal is to turn rugged wilderness islands into a giant harbor that moves hundreds of thousands of container boxes daily, all without a single human worker. No crane operators, no truck drivers, and no eyes on the ground. To build this autonomous beast, you must completely rewrite engineering rules. This is your step-by-step blueprint to build a global megaport. Your first major task is to find the perfect water depth. Modern megaships carry massive payloads and need 15 meters of clearance. If you build near Shanghai's historic rivers, you will fail instantly because the Yangtze River estuary drops over 100 million tons of mud yearly. This continuous sand buildup creates shallow barriers that trap large vessels. Even constant dredging caps your maximum depth at 13 meters, meaning fully loaded container ships will get stuck in the shallow mud, forcing captains to wait outside for high tide cycles. This tidal gridlock wastes millions of dollars and stalls global trade. To fix this depth crisis, you must abandon the mainland entirely and locate a pair of rugged granite peaks in Hangzhou Bay. The Yangshan Islands are surrounded by natural, deep ocean channels where fast sea currents naturally scour the seabed, keeping it clear. This environment guarantees a permanent 15-meter depth class for ships. You have found your deep water site, but now you face a new nightmare. You must somehow turn jagged granite rocks into flat, concrete yards. To build your flat yard, you must conquer a terrible mud nightmare. The ocean floor here is covered in thick, soggy marine clay, a soft mud slurry with zero initial strength to support heavy weight. Heavy containers and giant metal cranes would sink straight into the seafloor. To fix this, you must deploy a unique sand sandwich layout. First, you pump a clean horizontal blanket of sand across the mud, and then you drive thousands of plastic vertical drains deep into the clay. The sand layer keeps these long plastic drains from bending or breaking, ensuring that water has a clear path to escape upward. Next, you hook massive vacuum pumps to the underground pipe network and apply a powerful negative suction pressure reaching 80 kilopascals. This extreme suction aggressively pulls out the trapped pore water, causing the loose soil grains to lock together. This vacuum preloading tricks physics, increasing the raw strength of the clay. Now the ground is stable enough to support your heaviest construction gear, but you still need to make the soil dense and rock hard. You bring in massive steel weights hanging from giant crane towers and drop these heavy tampers from heights of up to 30 meters. This delivers thousands of kilonewton meters of raw smashing energy per blow, forcing out hidden air pockets and compacting the soil. Finally, you must protect your newly made land from the open ocean. You build massive rock-filled breakwaters all along the perimeter of the terminal to shield your flat foundation from fierce waves and erosion. You have successfully stitched islands together, but you are still marooned at sea. You need a way to link your island port directly back to the mainland, which means you must build a giant sea-crossing highway called the Donghai Bridge. The bridge must span a massive distance of over 32 kilometers and survive major earthquakes, huge typhoons, and fierce ocean waves. To protect loaded cargo trucks from strong crosswinds, use an S-shaped path. This unique curve reduces wind drag and stabilizes traveling vehicles. Next, you must anchor the bridge deep into the soft marine clay. Your teams must drive 8,712 piles into the seabed, including over 5,000 steel pipe piles for strong structural support. In the deep water zones, you anchor directly into underlying bedrock. To prevent underwater erosion, drop gravel bags precisely around the pile bases using specialized boats equipped with real-time tracking to place materials perfectly. Finally, you must continuously monitor the bridge's structural health by installing over 200 advanced sensors across the entire highway. These sensors measure real-time wind speeds, strain, and wave impacts, ensuring your offshore lifeline stays completely safe. To automate horizontal transport, you must build a hidden underground navigation matrix. You deploy a fleet of 130 automated guided vehicles, AGVs, across the yard that must navigate flawlessly without a single human steering wheel. To achieve this, embed 61,500 magnetic nails into the concrete pavement, drilling and placing these markers in a precise geometric layout. Map every single nail with millimeter accuracy using satellite tracking networks. As the driverless trucks move, onboard sensors read the magnetic fields below, and the vehicle's computer cross-references the data to calculate its exact position. This grid network gives your automated fleet centimeter-level positioning accuracy. Next, you must program the path planning system to prevent gridlock using advanced AI algorithms to ensure no two trucks try to occupy the same spot. Keeping this autonomous fleet coordinated requires an ultra-fast wireless network where central data commands achieve a continuous latency of under 50 milliseconds. If the connection slows for even a moment, a safety stop triggers, causing a network lag that would instantly freeze your port and ruin operational efficiency. Traditional industrial Wi-Fi networks will fail under heavy signal interference. To solve this, deploy a custom 5.8 GHz cellular network designed by tech giant Huawei. It easily handles up to 60 driverless vehicles per berth at once. Mount the cellular base stations directly onto existing port lighthouses, spacing them exactly 250 meters apart to save construction costs. You now have a subterranean navigation grid, but you still need heavy machinery. Now you must build the heavy mechanical muscle to handle the massive cargo containers. You bring in heavy machinery built by the engineering giant ZPMC, installing 26 massive double trolley cranes right along the waterfront edge, alongside over 100 automated gantry cranes inside the storage yard. To speed up operations, the main cranes use a unique double trolley system. The first trolley is run by a remote worker sitting miles away, lifting the metal container from the ship onto a middle platform. The second trolley runs completely on its own using computer vision, snatching the box from the platform and lowering it onto a waiting vehicle. To achieve driverless alignment, mount advanced laser scanners onto the lifting frames. The system uses 3D laser points to map out the target box shape, while onboard computer brains calculate the exact location and tilt angle of the container. Hydraulic cylinders automatically twist and shift the frame to align with precision, utilizing a smart loop that locks onto the target corners down to the millimeter. This setup completely eliminates human error, running perfectly during dark nights or heavy fog. Finally, link all crane cameras to a central room using fast fiber optic wires, allowing a single office worker to safely manage multiple automated cranes simultaneously. To control this massive robotic harbor, you must code a custom digital brain. The port utilizes an advanced software platform called the Terminal Operating System, TOS. This custom brain instantly creates unloading and storage maps for massive cargo ships, completing complex logistics calculations in 15 minutes instead of 4 hours. This automated orchestration slashes manual on-site harbor labor requirements by 70%. A tiny crew of 400 people can move 26,000 boxes daily, whereas a standard port requires over 1,000 workers to handle that same volume. This data-driven setup increases your overall operational efficiency by over 200%. However, your automated port still faces a major land transportation logjam as thousands of containers must travel across the 32-kilometer bridge to the mainland. To solve this, deploy a fleet of fifth-generation autonomous heavy trucks. These self-driving vehicles travel across the open sea in tight platoon formations using high-speed vehicle-to-everything V2X signals to share real-time braking data. Driving in tight, computer-controlled blocks increases bridge traffic capacity by 40%. Advanced laser sensors scan the road to prevent collisions under heavy crosswinds, while the trucks navigate thick fog and dark nights using precise satellite maps. They park at crane lanes with a precision margin of just 3 centimeters. This clean energy autonomous fleet ultimately saves 80% in traditional driver labor costs. Building this offshore robotic empire requires a truly staggering financial investment. The 32-kilometer Donghai Bridge alone cost over $1.2 billion, and total spending on the overall island port complex runs deep into the billions. But these immense upfront construction costs unlock massive, long-term financial rewards. The automated crane and truck network slashes traditional driver labor costs by 80%, and replacing older diesel fleets with clean energy trucks creates a massive environmental victory, dropping dangerous carbon and greenhouse gas emissions by up to 60%. The massive system-wide efficiency boost changes the speed of global trade entirely. A tiny crew of 400 people can handle 26,000 boxes daily, achieving a massive 200% increase in overall port efficiency. These upgrades helped Shanghai process over 55 million container boxes in 2025, comfortably securing its title as the busiest container port on Earth. The offshore Yangshan Islands handle over half of this entire national shipping traffic, serving as an unblockable economic gateway connecting China straight to global markets. Building a ghost port shows that modern trade is no longer about muscle. It has transformed into an aggressive war of automation, data, and algorithms. By moving 32 kilometers out to sea, engineers bypassed natural river limits and built an unblockable, self-running engine at the center of global logistics. The offshore automated megaport is officially online, running the world and changing the rules of global shipping infrastructure forever. If you want to continue learning more about modern China, then make sure to subscribe, and see you in the next video.